a circle. And when we say, I made a circle, that's what we're saying. But now I'm just going to draw a radius line from the center out to the periphery. That's the radius. And I could draw an infinity of radii from the center to the periphery, and they'd all be the same length. That's, again, a circle. But now what I'm going to do is I'm going to use that to generate another form. And this form is called the vesicoplacis, the mouth of the fish. And the way that works is I will take the point where my radius touches my circumference, and I'll use that as a new point, and I can see if I put my compass that I haven't changed the compass. It goes right back to the center of the original circle. So I'm going to use that point to generate another circle. Whoop. And then I have this area in the center, the mouth of the fish. And in Chartres, over the door, you would see this, and in the mouth of the fish, you would have Christ the fish, the places, speaking of the creation of the one begats the two, and the two begats the three. So now this line here is a generative line for a new form. So if I took this point here, I could go from there to there, and I see it's the same line, it's the same distance. From there to there, it's the same distance. From there to there, it's the same distance. Those 3 points generated by the vesicoplacis are all the same length. They are all equal. So I now have the great magic form, the equilateral triangle. The equilateral triangle is the basis of all mineral forms. It's magic. Now, it is the archetypal triangle. And I'm going to say something a little strange here.
Really? Okay.
I'm going to take this and I'm going to say to you, that is a triangle. Okay, that's what I said, it's a little strange. And now we're going to do an exercise, and hopefully by the end of the exercise you will be able to tell me why.
Tell you why.
Why? Tell me why. Okay, so the exercise is, let me break. Let's just, the person on the end of each row, just count halfway down and get one pair of scissors for every. Oh, you already got them. Awesome, awesome. Somebody was thinking. That's great. Wonderful. So you don't need a lot. So if you look on your handout, look at figure 13. Figure 13 is an equilateral triangle, a right angle triangle, and then some twisted triangles. What I'd like you to do is using scissors, if you cut a triangle out of the center of this paper. So if you want to do it the easy way, you just take a little pinch and just pinch and then snip that with your scissors. You can draw any kind of triangle you want and snip that and then just cut that out so the triangle is a whole. Don't do it now. Don't do it now, but I'll explain the whole thing and then we can go. So you're going to have a triangle, any kind of triangle you want to cut out of there. But it has to be a triangle. Then I'm going to say something even a little stranger, as I'm prone to do. So we're going to do an experiment. I'm going to say to you that my line of sight, I want to hold this triangle that's cut out at perpendicular to my line of sight. But I'm going to say to you that no matter what triangle I cut out of the paper, I can match it point for point and side for side with this equilateral. Okay, that's why I said don't do it yet. I don't want to explain it to you. So, so this is a test. So you're going to cut a triangle out of here, whatever you want. And the rule is you hold the paper perpendicular to your line of sight, 90 degrees to your line of sight. And then you look through the hole at this. And I'm going to say to you that keeping those two things the way they are is possible to line up the points on your cutout and the sides of your cutout exactly with this equilateral. But you're going to have to figure it out. So cut it out, and then we'll do it silently because we're going to watch the 100th monkey happen.